In this problem, what we want to do is we want to graph this function and its inverse. So the first thing you can do is you can make a table of values, and you can use your calculator, or you can do these by hand. These are the numbers that I generated. -1, -1.6, and then 1.71, and then 2, 3. So now let's graph these. So we have -7, and then -1.9 is roughly here, really close to 2, and then -1, and then -1.6 is roughly right about here, and then 1 and 7.1 going to be somewhere right about there, and then 2 and 5.3 is roughly right about here. Okay, so now what we want to do is we want to connect it with a solid Now, it might be off just a little bit, but this is close enough. This graph is of y equals e to the x minus 2. Now, most of you know that to get the inverse of this, all we really have to do is switch the x and the y values. So this is -1.9 minus 7, -1.6 minus 1.71, 1, and then 5.3, and 2. And let's not forget 0. You're going to have -1 and 0, and then on the other graph you're going to have 0, -1, and that's this graph right here. So now let's graph our inverse, and the inverse we're going to have -1.9, -7, so -1.9, and then -7 is down here, so roughly here, and then -1.6, and -1, roughly right here, -1 and 0, and then 7.71 and 1, so roughly right about here, and then 5.3 and 2, right about here. So then we get a graph that looks like this. Now, to find its inverse, one of the things that we have is we have y equals e to the x minus 2. Well, to get the inverse, we learn to switch the x and the y. So then this becomes x equals e to the y minus 2. So then we have x plus 2 equals e to the y. Alright, now we are in exponential form, so what can we do? We can switch to logarithmic form, and we can say log base e of x plus 2 equals y. Now, we don't use log base e. What do we use? Natural log x plus 2 equals y. And this right here is the inverse. That is this graph right here. So what we want to do is, in order to do this problem, we've got to find first the decay constant. So first business we have to do for this problem So now we can use the formula for radioactive decay, e to the negative kT. Now, we know that if I have 1 unit of material and it goes to half of 1, that means 1/2, I know that it's going to take 1620 years to do that. So we have e to the negative k, and that's times 1620. So now what I need to do is find k. In order to get k, my variable, which is in the exponent location, I need to take the natural log of both sides. So we take the natural log of 1/2, and we also take the natural log of the negative k, 1620. Now the whole reason I do this is to get this into the front, because the properties of logs let me do that. So now I get natural log 1/2 equals negative k 1620 natural log e. Now, the natural log of e, what does that equal? 1. Anything times 1 is the same thing. So now I get natural log 1/2 equals 1620, I should say negative 1620k. I want to solve for k, so now I divide by negative 1620 on both sides. This cancels, and then what we get when we take and we divide is we get that k is going to be 0.000428, and that is our decay constant. Now the second part of this problem is they want to know, if I start with 20, how much is going to remain after 5,000 years. Well, again, I'm using the same formula, n of t equals n sub 0 e to the negative kt. So we're doing it for 5,000 years, and we're starting with 20 grams. E, I know that k is negative 0.000428 t. And what do we know t is in this case? What are we plugging in? Well, we're plugging in 5,000. So we get n to the 5,000, so we get 20 e negative 0.000428 times 5,000. Now, at this point, this is a calculator problem, and when you plug this into the calculator, you're going to get 2.35 grams left after 5,000 years. Alright, what we want to do here is, it says the Richter magnitude M of an earthquake is related to the energy released in ergs E shown by the formula. How much energy is released by a 4.5 magnitude earthquake? Well, we did some problems with this, and what we have to do is substitute 4.5 in for M equals 2/3 log E divided by 10 to the 11.8, and what I want to do in this problem is I want to figure out the energy, so I need to figure out what E is. So before I can get E out of here, I need to multiply both sides of the equation by, if I multiply both sides of the equation by 3/2, so I multiply by 3/2, that gets rid of this. Then I multiply by 3/2 over here. And so then that ends up with 6.75 equals log E divided by 10 to the 11.8. Now, we remember how to do these problems because what I can do now is I can physically separate this into two logs. And so I get 6.75, and I'm using the properties. So then it's going to be log e minus log 10 to the 11.8. Okay, so now we can do some more manipulating. What do we know? This right here is an exponent, so it can go around here to the front. So now I get 6.75 equals log e minus 11.8 log 10. Well, this is 10 to the 10, so what do we know this goes to? It goes to 1. So because this goes to 1, we have 6.75 equals log e minus 11.8. So now what do I have to do is add 11.8 to both sides, and when I do that, I get 18.55 equals log e. Alright, now we are in logarithmic form. So now, since we're in logarithmic form, what do we have to do? We have to go to exponential form. What's the base of this common log here? It is 10, okay? We don't write it in. So when I go to write this in exponential form, I get 10 to the 18.55 equals e. And this is my answer. And so I can keep it in this form, or I can physically take 10 and raise it to the 18.55 power, and what you get is 3.55 times 10 to the 18th ergs. And this is your answer. Either one would be correct. Alright, first things first, what we want to do is we want to change and figure out what x has to be for this to be a correct equation. And it says show all work to get answer, and then it says work outside in. So basically you're working from out here into this function. So remember, if I can't do anything with the logarithmic form, what do? I switch it to the exponential form. So what I get is 9 to the 1/2 power equals log base 2 of log base 4 of x. Now, as I can see, this is not going to help me. So now what I need to do is I now need to finish this up, and what I get is 2 to what power? Well, what's 9 to the 1/2 power? This is basically the square root of 9, which is going to be 3. 2 to this power equals log base 4 of x. Alright, now we still haven't gotten to the answer, and so then I do 4 to this power. Well, what's 2 to the third? 2 to the third is 8 equals x. And for this to be a correct statement, my answer would have to be 4 to the 8th power, or what? 65,536.